I work for a company called Norsk Titanium, and I come from Norway. I'm an automation engineer, and for over 10 years I've been programming, troubleshooting, fixing SCADA systems, PLCs, HMI, and all that. So I'm an OT engineer from the heart. So before we begin, I'm going to talk about Sparkplug, Confessions of an End User. Before we begin, how many of you know or have heard of Sparkplug B? Okay, most of you. How many of you will say you understand? Or okay, and how many of you have used it? Okay, maybe 20. And how many of you have used Sparkplug B in production? So 1, 2, 3, 4 hands. Okay. Yes, for the past 1.5 years, we have used Sparkplug B in production at Norsk Titanium. And what I'm going to talk about is our experiences using Sparkplug B and what we've learned. Oh, shit. Okay, so first of all, what do we do? So we're Norsk Titanium. We take titanium wire, and what we want, what the customer is going to get in the end is this. That's the finished product. It's a bracket, and in the middle there we have what comes out of our machine. So it's what we call near net shape product that is machined into this finished product. On the top there, you see our competition. So that's the traditional way of making this component, is taking a block of metal and machining it into the finished shape. So that's what we do. We have, this is from our facility in the US. We have a bunch of these additive manufacturing machines, and we not only make these parts that come out, we also are an OEM for these machines. So we don't build the machines ourselves, but we do the design and the software and everything related to the machine, so it's our machine, this RPD machine is what we call it. We have around 100 employees now, so we're a small company. We have 3 sites, and we have primarily development in Norway, and then in the US we have production. We are now in a phase where we ramp up from development into full-scale production. Yeah, this is at the core of our process. We feed titanium wire, and we feed it into, and then we melt it using plasma torches, and then we do that layer by layer and creating a near net shape finished product. This is a very fast process, and we monitor this down to 1 millisecond. So we're a small company, but we have lots and lots of data. So it's up to somewhere between 10 and 20,000 value changes per second when we're in production, per machine. Yes. So around 2 years ago, we were faced with a problem. We needed to scale up our data acquisition. And if what you see here is on the left end, we have the OT side, or that's the machine side. You can imagine we have one of these per machine. And on the right hand, this is centrally per site. So one of these per site. And we used to have a PLC. We're using a proprietary protocol, OPCDA, through an HMI data acquisition using Wonderware. And then we have Wonderware centrally as a historian. And then we used extract, transform, load to put the data into the cloud or a data warehouse. Yes, we were having problems scaling up this, and only when we were running at 10% capacity, for instance, these extract, transform, load jobs would take hours per day. So only at 10% capacity, we're having problems scaling. We had a bunch of other problems, like we didn't have this Wonderware is a proprietary system, so we didn't really have any insight into the real-time state outside of this Wonderware platform, and a bunch of other problems. But yes. So in order to understand the solution, you also need to understand the problem that you're trying to solve. So data acquisition, how it's always been done. So in traditional data acquisition, it's always been a server-client setup. You have a server that wants the data, and you have a client that has the data. Sorry, the server has the data, and the client wants the data. And then we do poll response, so that's, I need, yes. Okay. Sir, what's your name? Johan. Could you put your hand in here? Okay. Yes, and I need a volunteer to help me out with this one. Okay, great, thank you. Okay, so you're going to be a PLC, and I'm going to be a SCADA system wanting that information. So I want to know, what's your age?
48.
48. What's your age?
48.
What's your age?
48.
What's your age?
48.
Okay, what's your age?
48.
48. Okay, we keep doing this because we do poll response. Yeah. If I wanted to know the age of everyone in this room, you would understand that that creates a lot of, costs a lot of bandwidth. And you say you were 48?
48.
So is that Gen Z? So you're, and I know you're from Sweden. So you're a Gen Z Swedish model, so you have a particular code I need to ask you to get that information from you. You can write that down on a piece of paper here. Like Q5 or... Okay, can I have that? Yes, thank you. Okay, so when I ask QR3, QR3,
48.
QR3,
48.
QR3,
48.
okay. But I don't, is that in years or is it months? How, I mean, you need to write down, is it months or is it years? Okay, thank you. Okay, we have, it's in years, everyone, so. Okay, QR3,
48.
QR3, okay, you get the idea? What I'm holding now in my hand is a kind of a signal list. Because in order for me to get that information from you, I need a priori information about that information in order to get the information. And that's why we used to do these kind of signal lists. They're usually made in Excel or something like that. And it contains information about the data you want to collect. And that needs to be distributed to different people, engineers, systems, put into the systems, etc., etc. So that's how you used to do data acquisition. Okay, so in comes Sparkplug B. And what really is Sparkplug B? It really is just a standard, a specification for MQTT, topic, payload, and state management. That's it. It's designed for industrial applications. And that's important. And why do we make standards like this for communication? Why do we want a standard like this?
You don't need information about your information.
Yeah, but why would you need information about your information? Compatibility, yeah, or interoperability, right? Yes. So that is what Sparkplug is. But what does it do? So Sparkplug B gives us interoperability, but it also the features that it contains is plug and play. So between two systems that are Sparkplug compliant, it is supposed to be plug and play. But features include also auto-discovery, meaning if I have a new PLC and I want to get the data from that one, with Sparkplug B, I plug this PLC into the network, and the systems that are part of this network will auto-discover that asset. So that gives me auto-discovery. It also gets me properties and metadata, so like the units of measure that I got from you. And I'm a simple guy. I've always wanted something that gives me, I create these beautiful UDTs inside of my PLCs, and then I have to recreate them in the SCADA system. I have to recreate them in the historian. I have to recreate these UDTs all over the place. And Sparkplug B gives me the opportunity to have the UDT defined in one place. It's also lightweight, report by exception, protobuf compression, so I don't have to, I know that it can scale much better than poll response patterns. I also don't have to worry too much about collecting too much data. And I would rather sit there having too much data afterwards than missing data when I would have needed it. It also supports store and forward. I don't want to lose data, so if there's a disconnect, Sparkplug B handles store and forward. And you can also do commands. And I want to be able to control the PLC or whatever I need to control from a SCADA system or other system. So this is not going to be an in-depth explanation of Sparkplug B, but I wanted to go through birth certificates. So let's say Yuan, your namespace is your age, where you come from, and how many kids do you have. That's your namespace, so to say. And when you enter the network, you come on the network, and then you send a birth certificate. And then you tell everyone your...
48, Sweden, and 1.
Yes, okay? Yes, yeah. So that's the first scenario where a birth certificate will be issued in the Sparkplug network. So that everybody now knows your namespace and information. But say that I leave the room for a little while, and then I come back. And because it's report by exception, I have no idea if I missed the message that you had another kid. So I don't know if you had another kid in the meantime. But so I need to now ask you, can you please send me that birth certificate again?
Yeah, 48, Sweden, and 1.
Okay, thank you. So that's how birth certificates work. It's a kind of hello world, here's my namespace type of message. And that's how you get the auto-discovery part of the Sparkplug. Okay. So back to our problem. And back to those signal lists, we used to have 4 points of configuration in our system. We needed to expose this on the PLC. We needed to set up this gateway communication here and assign this PLC address, blah, blah. We needed to do the same here in Wonderware, needed to know what the gateway address was. And then thirdly, we had to do that for the extract transform load as well. So you had 4 places to configure for every new data point. So this is our solution. We use Opus UA and Sparkplug B. So we had PLCs that supported Opus UA, so we just implemented that. And we also automated that we expose everything. We don't choose what we expose everything. And that could be automated. On the edge, we have this edge gateway, which takes Opus UA, turns it into Sparkplug B, and then we do some real-time analytics if we need to. And then that's our only place of configuration. And what we do there is we get the data, and then we also transform it or normalize it, and some modeling. And then this data is then sent to MQTT, and both the cloud, we have Ignition platform and a Canary historian that both can get this data. Okay, so now on to what's the good part about Sparkplug. What does this give us? I couldn't help myself, but Where we're going, we don't need signal lists. I have a video here. So this is from our Ignition Central. And what I'm showing is just there's nothing up my sleeve. There's no tags in the namespace or anything. And what I'm going to do now is just connect Ignition centrally to the broker. We already have the edge nodes publishing to the broker. So what you can notice is all this data appears. It's around, at this point, it was 60,000 tags. We have now, yeah, I don't know the number, to be honest, but more. And you can also see it's not just like data and values. There are data types, meaning these UDTs. They're also there. So that was 60,000 tags or so in less than a minute, but yeah. So the other thing is that once we've configured metadata, like documentation, engineering units, etc., on the edge, all consumers of that data have that information. So both Ignition centrally has its engineering high is 1,500 liters per minute, and the same goes for the Canary historian. So it has 1,500 liters per minute. So, and the other thing we can do is we can make a namespace-defined SCADA / dashboarding. And as you see, we have many machines. They are not necessarily in the same type of revision as far as software and features and functionality. So then we can have the Sparkplug define these objects and what it contains and doesn't contain, and then our SCADA system automatically reflects this. So we don't have to configure that part. The same is true if we add the machines to the network. They just appear in the SCADA system because of this auto-discovery. Another thing it gives us is that rather than having Wonderware being the source of truth for our current state, we now have this open architecture. MQTT is the source of the current state for all our machines. Yes. Another thing it has given us is autonomy on the OT side. So because we have one place to configure, we in OT are able to add stuff to a single machine that we are testing something, developing something. We can add tags, and it will automatically show up in the SCADA and the historian, and we don't have to involve IT with these 4 places of configuration. We in OT can do a lot on our own without involving IT. So now over to the ugly. Something I call burst storms can happen. We had one instance where one of the Canary collectors, one of these Canary instances, were struggling with disconnects from this broker. So once every 1 minute or 2 minutes, it would disconnect, reconnect. So it would, and then ask for burst certificates from all our machines. And that's, let's say, 300,000 tags. That's a lot of data. So it would do that every 1 minute. So then it's not so lightweight anymore. It's actually quite hard on the network. That eventually crashed the collector because blah, 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 lots of data, everything. So that wasn't good. Another thing to be careful about is template conflicts. Because our assets are the machines are the same, but they're not the same. They're very similar. They mostly contain the same templates or the same UDTs. But if we update one and then there's a conflict between two two templates. So we need to be careful about creating template conflicts. They can be actually hard to clean up, but that's not because of Sparkplug, but because of the systems we're using. There's also this all or nothing that Mark mentioned. You either need to subscribe to all the data or none of the data. So you can't pick single data points. You have to take everything. A third thing, and this is a unified namespace related thing, is that there's no native namespace aggregation, meaning the Sparkplug namespace of an edge of one of the nodes in the Sparkplug is the namespace. I can't add to that namespace later on as I move up the stack, not natively. What we do is we add memory tags that we write to using the D command, if you want the details. We can do that. I mean, we can add context, but it's not non-deterministically. We have to add that here in the gateway before we can write to it. So it's not dynamic. Yes, another thing is primary node. In order to have a store and forward mechanism, you need to set one node as the primary node. And if Canary then disconnects, this will stop publishing data, meaning that Ignition loses the live stream, and the cloud loses the live stream. So that's not what we want. We want Ignition to be able to control the machine, even if just the collector is down on the historian. So that's the ugly. But yeah, so to summarize, our key takeaways really is that Opus UA plus Sparkplug B is awesome. We have Opus UA on the edge, meaning I can control how fast I sample, and I can select the data I want to collect. So I get the control of Opus UA on the one end, but then I also get the simplicity and the plug and play and the UDTs and the templates and the properties and the metadata and all of that I want from Sparkplug B. So combining these two, I think, is great. Another thing is don't use Sparkplug B for everything. It's like with any technology, there are benefits and there are drawbacks. And if the drawbacks outweigh the benefits, don't use it. We found that for our sake, the benefits outweighed the drawbacks, so we used Sparkplug B. And one of those, you mentioned it, Mark, one of the key things is, are you using off-the-shelf software that support it? If you don't, it may be better to just use a different standard or make your own standard. All right. Thank you. Yeah.
Would you like to take some questions? Henning Heine from Wolf in Mainburg.
Hi.
I know you from the internet. It's super interesting what you described when you talked about the burst storms, because that's actually the reason why we abandoned Sparkplug, or most of it. How did you overcome that problem?
Not really.
So your canary is still disconnecting once per minute?
No. I mean, we fixed that problem.
Okay,
yeah.
but it's I think that's the main challenge if you have multiple interested parts listening to Sparkplug, and one goes down, and it will directly ask for rebirth, and sometimes they will the sequence numbers will not match, and then you have the first node ask for rebirth, the second node ask for rebirth, and it goes on and on. It's
we've had that happen where it's like a continuous this back and forth. But I don't know if I have a fix for you, but it doesn't happen. I mean, it doesn't happen now.
Okay.
Yeah, that's what I can say.
Okay, our fix was to abandon it, but I had to ask. Thank you.
Yeah.
Danke. So, John, it seems that you showed that you were abandoning the old architecture where you had, for example, Wonderware SCADA and you actually removed it and moved into your modernized architecture. Is that true, or you still have a hybrid?
We have a hybrid. So Wonderware is still running in the background. We need, primarily we deliver to aerospace. So we need to prove this architecture over some time before we can remove the existing.
But Wonderware is then a data producer and consumer in the broader scale, in your UNS.
Yes and no. I mean, we just use it for what we have to use it for at this point. We don't use it for anything else.
Thank you.
Yeah.
Hi. Maybe I didn't get it right, but did you say that when your historian gets disconnected, then also your device stops publishing data? Why?
That's how the this primary node, what's it called? Primary host works. That's how the Sparkplug. I don't know if it's in the spec, but that's at least how it's implemented in the ignition. That if the primary host disconnects, the node producing the data will stop publishing, holding the data in store and forward until the primary host is back. When the primary host returns, it will then publish and do all the store and forward backfilling, etc., before it then comes online again.
So this has something to do with this ignition primary stuff?
I don't know if it's a spec thing or if it's an ignition thing.
Okay.
Yeah. It's a spec thing? Yeah. Yeah, there you go. Yes, yes. I mean, the solution for it is actually just have another Sparkplug publisher that publishes on the side. But then you have two, so it's kind of not optimal. But that's what we do. So we have two publishers, one for, but yeah, anyway.
Seems to be strange.
Yeah, it feels unnecessary.
Hi. You said that the machines you use generates data every millisecond, right? So how do you handle such a huge data producing? Do you use same approach? I mean,
we don't use OpenCUA for that. We have a custom thing where we do some things. But we don't use OpenCUA for that. We use something else.
Okay, thank you.
Yeah. It's partly, that's why also the reason we use Sparkplug B is that it has this native timestamping. It's part of the standard. So if we want data to be timestamped correctly and have essentially timestamped correctly from the source, we use Sparkplug. And we have written custom clients ourselves using Python, for instance. We have done that.
So what would be your wish for the next iteration of the Sparkplug protocol?
Fix that primary host thing and free up the hierarchy. So you can have the hierarchy how you want it and fix this all or nothing thing.
So UNS support and a bug fix basically.
Yeah.
Nice.
That's the most critical things. I mean, there are a ton of things you could wish for, but fixing the ability to then have namespace aggregation, able to only subscribe to parts of it, and this primary hosting. That's the most important things for Sparkplug version 4, which is something they're working on. Yeah. Thank you.